We are talking about transformations of quadratic functions. We want to graph quadratic functions in intercept form, and we want to write the equation of quadratic functions in intercept form given the x-intercepts and a point. So we have graph h of x equals negative x plus 2 times the quantity x minus 4, and compare it to the parent function. And we want to calculate the given information. So the first thing is we want to calculate the x-intercept, and that is going to be from the zero product property. So that just means if this is equal to 0 or this is equal to 0, then the whole thing is equal to 0. So the first one we can take is we can set x plus 2 equal to 0, and we subtract 2, and then we get x is equal to negative 2. Next one we can look at is the other factor, and we get x minus 4 is equal to 0, so we add 4 and add 4, and then we get x is equal to 4. So we have two values there, and so we'll go over 1, 2, 3, 4. So we have the point 4, 0. And then we can count back 2, 1, 2. And we have the point negative 2, comma 0. Now the line of symmetry, or axis of symmetry, we calculate that from our x-intercept. So x equals the divide sign always stays, the addition sign always stays, and we always divide by 2. The things that change are we are going to add the p and the q. So we add those together and take the average of those, and that will be our line of symmetry. So p in this case is 4, and q in this case is negative 2. And the things that always stay are we're always going to average, we're always going to divide, and we're always going to divide by 2. So 4 minus 2, and we get 2 over 2, which is equal to 1. So then we get our x value, our x-axis, is equal to 1 for our axis of symmetry. So we can sketch that on our graph. And then next part we want to look at is we want to look at minimum or maximum value. Our a value is negative 1. So if it's a negative value, we know that we want to have it open like this, concave down. So we're going to be looking for a maximum value. And the way that we calculate this is we're looking for our vertex. And so we get to substitute x equals 1 back into our original equation, and we get to see what we get for our vertex. So the function h evaluated at 1 is equal to negative 1 plus 2, and then 1 minus 4. And then we can substitute in our 1. And then we're left with -3 times -3. And we get the function h evaluated at 1 is equal to 9. So now we get the ordered pair of 1, 9 for our vertex. Well, we only have 5 spots here, so we're going to have to count by 2s. So we'll go 2, 4, 6, 8, 10. And we'll graph the first point up here at 1, 9. So halfway there. And then we can look at our parent function as it relates. So for our parent function, we say go over 1 and then up 1 and then over 2 and then up 2, up 4 and then over 3, up 9. So in this case, we're going to multiply again by -1. So instead of going up 1, we're going to go down 1. Instead of going up 4, we're going to go down 4. Instead of going up 9, we're going to go down 9. So from our point, we go over 1, down 1. So over 1, down 1. Over 2, down 4, 1, 2, 3, 4. And then over 3, down 9. 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9. And then we can use our line of axis of symmetry and count 1, 2, 3, 1, 2, 3, 1, 2, 1, 2, 1, 1, and then we can graph our parabola that way. And just get a sketch there. And then the last thing that we can look at is the domain and the range. So again, this arrow here has an x component and a y component. So that means that it's going to continue to -infinity, and this one components as well. This one means it's going to positive infinity. So the domain, we're thinking of the x values. So the x values say it's going to go from -infinity all the way to positive infinity, not included. Or excuse me, yeah, the infinities are not included because we'll never be able to count that high. The range, it's going to start in -infinity because we always start at the lowest value. So this arrow means it's going down to -infinity because we're looking for the y values. And so we're going to start at -infinity, but we won't be able to include it because we won't be able to count to that. And then we're going to go all the way up to the y value of our vertex, which our vertex is at 1, 9. So the y value is the 9. So we're going to make it all the way to 9, and 9 is included. And then decreasing or increasing. So it's going to start out increasing as we come from here. So it's going to increase from -infinity all the way to 1. One's not included. And then it's going to decrease from 1 to positive infinity, not included.